Do you like origami? Because I do. And we have a piece of paper here that we're folding. So good for me and hopefully good for you. It's denoted as PQRS. So that's just the rectangle, P to Q to R to S. And we're folding it along this line FH. Right, that's our fold line. And the point P is then translated to G. Right, so this white bit here is the underside of our piece of paper, and this is now nothing. Right, that's where the piece of paper was. We're given a few dimensions. Some of them are in terms of x, some unknown variable. We're reminded that the area of a triangle is half base times height. And our first task is to find the perimeter of the shaded region. So just to make that clear, the shaded region follows this green line. It's an interesting shape. All right. So there's a few sides that aren't labeled. Right? The perimeter is the sum of all the sides. We are given 2x plus 5. That's great. We're given x plus 3. But what about q to f? What about these ones in here, f to g or g to h? So let's have a think. 2 centimeters, f to p, would actually be the same as f to g, right? Because it's the bit of the same piece of paper but folded. So those are equal. So we know that that's 2 centimeters. Similarly, g to h is the same as p to h. But again, same bit of paper, it's just orientated upside down and folded across. So that's 3 centimeters. And then what would this dimension be, q to h? Well, we know the total is x plus 3, and then we're subtracting 2. So this would be x plus 3 minus 2, which is just x plus 1. And with that, we have all the sides, and we can find the perimeter by adding them together. So let's start it from the top. So 2x minus 5. To that, we'll add x plus 3. Uh-oh, I forgot one. Similarly to the x plus 1 side, we have a length of 2x minus 5, and then we'll minus 3. So 2x minus 5 is the total, and from that we'll subtract 3, which gives us 2x minus 2. All right, back to the perimeter. First side, second side, now the third side, which we just found, 2x minus 2. And then 3 plus 2 plus x plus 1. Wow, a lot of numbers there, but that's fine. We can definitely group like terms. So looking at the x terms, we have 2x plus x is 3x, plus 2x is 5x, plus x is 6x. We then have minus 5 plus 3, that's minus 2. Now we have minus 2, that's minus 4. Minus 4 plus 3, that's minus 1. Minus 1 plus 2, that's 1. 1 plus 1, that's 2. And I think I made a mistake somewhere. 2x minus 5, x plus 3. 2. Oh, I just caught it. You were probably yelling at me, but I couldn't hear you. This dimension is wrong. Why is that dimension wrong? Yep, I assume you said what I was thinking. When we did 2x minus 5, we said we would minus 3, but I actually added 3. So this dimension is 2x. This is why I show you working, and I didn't. Minus 5. And then from that, we'll subtract 3, not add 3. So that dimension becomes 2x minus 8. Whereas I wrote minus 2, because I added 3. So that's minus 8, which means we were off by minus 6. So 2 minus 6 is minus 4. Now double check my working now. That should be right. I am looking at the mark scheme too. Surprised I didn't pick that up sooner. But so the perimeter is equal to 6x minus 4. Do we know what x is? No. But we have found the perimeter in terms of x. Great. Part 2, find the value of x so that the area of the shaded region is 24 centimeters. Okay, so now we're solving for x because we're given some concrete information, in this case the area. You might be thinking, all right, how the heck do I get the area of this funny shape? Like, almost looks like a puzzle piece, really. You could be thinking, all right, maybe there's a rectangle and a triangle there. Break that one up there. Right, and then you have 3 rectangles and 2 triangles. Good luck with that. That's a lot of work. I don't even know if that's possible. However, getting the area of the bit of paper unfolded and then subtracting twice the area of this triangle, we can definitely do that. Right, so we have the area of the paper, but then since we folded it across here, and that came up over here, we've lost this area and this area. So area of the paper minus 2 times area of that triangle FPH will give us the area of the shaded region. So just in words, area shaded equals area paper. I'll just use symbols here. Area of the vertical rectangle minus 2 times area of that triangle, which has the sides 2, 3. All right, so that's what we're working with. And then we can equate that to 24 and then solve for x, right? Because this area will be in terms of x. All right, so the area of the piece of paper, 2x minus 5 times x plus 3. We can do that. 2x minus 5, x plus 3. All right, so that's the area of the rectangle. And from that, we'll subtract 2 times the area of this triangle, which is half times base times height. So half times base times height. Ooh. And that will equal the area of 24. Okay, we can expand and group like terms. So on the left-hand side, foiling this out, we get 2x squared plus 6x minus 5x minus 15. And then this can simplify inside the brackets. That's 3 times 2 is 6, times a half, that's 3. And then negative 2 times 3 gives us negative 6. We can group like terms. So 2x squared, no other x squared terms, so that's that. 6x minus 5x, that's just 1x. Minus 15 minus 6, that's minus 21. All equals 24. Great, so I see a quadratic equation emerging, and we know to solve that, it needs to be in standard form, which means I need to subtract 24 off of both sides, which gives us 2x squared plus x minus 21 minus 24 is minus 45, all equals 0. Right, so getting to here, great place to be. We have a quadratic equation. It's in standard form. We can now factorize and solve for x. Alright, we get our two sets of brackets equals 0. The coefficient of x squared is 2, so we know one of the x terms will have to be 2x. And now we need to think of what these numbers will be. Right, they need to multiply to negative 45. So 45 and 1 could be, or 9 and 5. So those are our factors. But to get negative 45, one of the factors needs to be negative. So we could try plus 9 minus 5. And to check that we're right, we need to then expand this out using FOIL and check that we get this quadratic. If we don't, we factorized it incorrectly. So let's just check. We get 2x squared, then we get minus 10x plus 9x minus 45, and these combine to minus x. However, we wanted plus x. So that tells me we actually got the signs wrong for the 9 and the 5. So let's try that again. So instead of plus 9, minus 9, instead of minus 5, plus 5. Now when we expand this out, and then combine these, that becomes plus x. So yeah, that works. So always just double check your factorizing by expanding it, because expanding is the opposite of factorizing. Okay, we haven't solved for x though, we've just factorized it. And then this tells us that 2x minus 9 must equal 0, or x plus 5 must equal 0. So 2x minus 9 equals 0, we could add 9 to both sides. We can then divide both sides by 2 to get x equals 9 over 2. If x plus 5 equals 0, we could subtract 5 on both sides to get x equals minus 5. Now, alright, we found the two values of x, but let's have a think. Can x be negative in this context? So if x was negative 5, this would have a side length of negative 5 plus 3, which would be negative 2. Doesn't really make sense for a dimension. So we say therefore x equals 9 over 2, positive x value only. Right, we've ignored the negative solution because it doesn't make sense. And we need to do that for excellence, which I know you can get. Keep up the good work.